Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SWE intern at Google.
So hello guys, I am Kumar. Previously I worked at Amazon and Media.net as software engineer, and now I spend most of my time in guiding and training students. So today is a very happy day for us because my lovely student Achut Gupta has cracked an offer from Google. So it's going to be a brilliant podcast where we are going to discuss many tips and tricks on how to crack Google OA and Google interview because many students are trying to get into Google. So
Guys, this interesting problem was asked in IIT for Google online assessment for software engineering roles. So this problem is based on dynamic programming and strings. But the main issue is that this is not a standard DSA problem. As we all know that in interviews and online assessments, Google generally tends towards asking hard and seen DSA problems. Okay, so if you're preparing for Google or FAANG type companies in 2026, try to practice more and more hard and seen DSA plus OA plus CP problems. And like I know most of you have done the standard DSA sheets or you guys are doing the standard DSA sheets, but you should know that that is not enough. You can see that this question you will not find in any sheet. You will not even find this question in lead code. So you need to practice the previous OA problems and lots of contest problems from Code Forces, Code Chef, and lead code. Also, I have one more tip which I would like to give is that in lead code discuss section now all the recent company interview problems keep on appearing. So you should try them out as well. You will see that they are also new in nature, mixture of multiple concepts. For example, this problem given to us in front of us is based on strings, dynamic programming, and very high quality observations. So you'll have to mix these three topics or patterns and you will have to focus on these things to be able to crack this particular problem. So let's directly try to jump into the problem. So the actual problem is not that difficult, guys. The difficulty is mainly arising because the language of the problem makes it difficult. You can see that you are given a string. You can perform the following operations any number of times from index 1 to n minus 1. One based indexing we have to consider for the string. You can swap s of I with s of I plus 1. However, if you change it, if you choose to swap at index I, then you cannot swap at index I plus 1. You must count the number of distinct strings that can be formed by performing any number of such operations. So see how complicated it is. They are saying that let's say we give you a very big string. Okay. What you can do in one move is, let's say this is your string. Okay. This is your string S. Let's say here there is a and here is a B. You can select to do special operation at index I and I will get swapped with I plus 1. And the final output will look like this. Like B will be here, A will be here. You can do this operation any number of times at any place. But the problem is that if you do the operation at index I, then guys, this thing has been covered. Now you cannot do the operation on I plus 1. Basically, you cannot swap I plus 1 with I plus 2. See, if you have swapped I with I plus 1, then you cannot swap I plus 2 with I plus 1 with I plus 2. Okay, this swap will not be possible. So this makes the problem very complicated. But if you try to imagine, you will understand that in short, they are saying that select independent blocks. Basically, it's not written clearly in the problem, but if you go through many test cases and you have done similar problems, the understanding is pretty simple that if you select index I, then you can never select index I plus 1 or index I minus 1. You guys cannot select these indices for doing the operation. If you select I, it means you're going to swap I and I plus 1. Okay, you're going to do this. But now you cannot do the operation of this red operations cannot be done. You cannot swap I plus 1 and I plus 2 now. This is not allowed. Okay. And this red operation is also not allowed. You cannot swap I minus 1 and I. These things are not allowed. In the question, they only told that if you have done the operation at I, you cannot do this I plus 1, I plus 2 operation. But that also indirectly means that you cannot do this operation also. Why? Think in terms of converts, right? If you first did the operation at I minus 1 I, then you would have done this thing, right? And then the logic would be that you cannot do operation at I. That's why this red block and this green block cannot overlap with each other. So overlapping swaps are not allowed. So if I try to make the understanding of the problem easier for you, the thing will be very easy. The thing will be like, let me like just go a little bit up. Need to generate some space for you people. Okay, so guys, the understanding is simple. Given a string, select some non-overlapping blocks of size 2 and swap the characters in them. by doing this process, how many different strings can you generate? How many different strings you can generate? So find it out. That's it. That's what the problem is asking you. So you can just be happy and try to do this thing. Okay. So let me take a lovely example for you. Let's say we have ABCD with us. Okay. We have ABCD with us. Okay. So listen, ABCD. So what can you do actually? You can select multiple blocks of size 2 which are not overlapping. So you can select this block, and the new string which you will get will be ABDC. You have swapped it. Or you can select this block, and the new string which you will get is ACBD. Or you can select multiple blocks like this one, and the answer will be BADC. Okay. So many things you can do. Whatever blocks you select, they should always be non-overlapping in nature. So total, how many strings are you able to generate? 1 string, 2 string, 3 string, and 4 strings. So the output for this problem will be 4. Output for this problem will be 4. Okay. So that's the problem, and how to apply dynamic programming on strings to solve this problem. Let's try to think about it. Guys, the thing is that you should learn these days DSA in such a manner. If you're doing DSA, you should do DSA in such a manner such that you are developing the nerve. You are developing the nerve for doing unknown problems. Whenever an unknown problem appears in your online assessment or interview, it can be a little bit unknown also, but you should not fear. You should be able to reach the logic in some time. So guys, the best way to do my 51-hour free course. My 51-hour free course on DSA plus OA plus CP. That is very, very brilliant. Please do it. Its link is videsiqna.in. Let me give it to you. So if you are watching this video now, guys, you need to do the dynamic programming part of that. So just let me write it in the prerequisite only. Before you go ahead, please watch 5 DP videos. Okay. Please watch the 5 DP videos of this, or else you will not understand what I am going to teach you further. From now on, I will assume that you know dynamic programming and you know how to apply dynamic programming on strings. Okay. So what you can do is simply go to this website, my lovely student selections. You can see, just hover down. If you don't know other topics, then do these things also before going to DP. But you need to watch these 5 videos on DP, and they will totally open up your mind. Just watch them one time. There are PayPal OA problems, at coded DP problems, very high quality ones. It will improve and strengthen your skills. So once you have done this, it means your logic based thinking is getting stronger and stronger. Nice. So now what to do? Now how can we apply dynamic programming to solve this? First, we need to do some crucial observations. You can see that swapping can give these different results. But guys, the first observation is you should never swap. You should never swap. You should never swap I with I plus 1 if both of them are same. If S of I is equal to S of I plus 1. In that case, you should never swap. So let's say you have a string B, C, A, C, D. If you try to select this block of size 2 and try to swap, you're gonna get the same string only. So the first observation is pretty clear, right? Observation 1. Trick 1. Let me write it as trick 1. Never swap two characters which are exactly equal. Okay. Never swap two characters which are exactly equal. Okay, this is going great for us. Then the second thing is, guys, this problem leads to lots of confusion because see, I will tell you what the programmers are generally thinking. If this is index I, like if you try to use the DP approach also, then also there is lots of stress actually. You might not try to swap it. Then you will see that the best answer is till here, right? If you till here, whatever was DPI minus 2. But if you try to swap it, then you will swap these two things, right? But guys, there is one more option. What if you are not swapping I, but you are swapping this? What if swapping this is giving you similar string as this one if this part was swapped? So this is very complicated, getting confused, right? So how to erase the confusion? So the confusion will be erased if we know that whatever blocks we will select, whatever blocks we will select will be non-overlapping in nature. Their size will be 2, and in those blocks, S of I will not be equal to S of I plus 1. So guys, my next lemma is each valid block you select will generate two different strings. Will generate two different strings no matter what. Hence, all the blocks each valid block you select will generate two different strings at that point. So by visualization, you can make it sure that every string you generate will be distinct. So let's take some example, right? Let's take some example. Let's say that your string was BCB. Okay. Yes, there are some characters on the left and on the right, but let's say we are only focusing on the BCB part. So this was our string. Let's say in one of there are many different ways to select the blocks, right? Let's say in way one, you selected your block like this. You just selected this thing called as CB block. And here you selected something like BC block. So the fear comes now that B will come here and here also B will come here. So these both strings will look similar even though the ways are different. No, different ways will generate birth to different strings. This will be what? BBC and then dot dot dot. This will be what? CBB. So guys, even in the worst test case, you can see that yeah, this is same, but these characters are coming different. Now you can say, but sir, I can prove you wrong. What if you selected a block where both characters were same? I told na, never select a block where both characters are same. If you're doing that, you are a fool. Sorry for the over exaggeration. You are not a fool. You're a very intelligent guy. I hope you understand my feelings and emotions. If you select any block which has two same characters, it's gonna stay the same. It is not going to generate any different string. So no matter what type of string you are selecting, if the blocks you are no matter what kind of string you have, if the blocks in configuration 1 as well as configuration 2, let's say they are different blocks which you have selected, the output will always be different strings only. If you have, as we know that the valid blocks are the ones where the two characters are not same. Now, if you say that, sir, what if I select the same block in both the strings? I select this block, let's say this was AB and this was AB. If you select same block in both the string, then both the ways are same only. Why will you count double times? But yes, you can say that way one is you select AB block here and CB block here. Way two is you select AB block here and then BC block here. No need to worry. The dynamic programming which we are going to make is going to handle these cases nicely. Why? Because everything will be very nice here and there will be actually no problem. Okay. So in this case, what's going to happen? So BCB, right? What it will give birth to? The AB, there will be two options, right? It can be AB and it can be BA. You can like see that in front of your screen. It can be either AB or either BA, right? And then let's go to BCB. So what's going to happen here? It will either remain BCB only or it will become, let me check, BBC, or it can become what? Let me check. CBB. Okay. So one option here, two option here, three option here, and two here. So this AB can combine with all these three options, and this BA can also. So that it will be like 2 multiplied by 3. There will be 6 options actually. Okay. So you can see how nice the things are going on. Okay. Like we can do so many things here without any worries. Ram Ram. Let's go to the next part now. Now let's see how can we apply dynamic programming to this lovely problem. So guys, see the definition of DP we will keep very simple. DP of I will just tell you very simple, like very simple. Because we have used a trick 2 na, because of the trick 2 we are able to now make the DP states. Like most of the educators would just explain the DP formula, but they would not explain you why it's working. It's working because of the trick 2. Because everything generated is always distinct. You can trust the process, trust the universe. DP of I means what? How many distinct strings can be generated from I to n. So if you only take this much part from your this suffix I to n, how many distinct strings can be generated? So let's try to solve it for A, B, B, C, B. We know that the answer is 6, right? So let's see how we can reach 6. A, B, B, C, B. So it is what? 1, 2, 3, 4, 5, right? So let's take the smaller part of it. Let's only take the last part. So if there is only a single string, how many different strings you can generate? Only one, you cannot swap. So dp of phi is 1. What is the meaning of dp of phi? Dp of phi means if you were solving only for this much part, then what would be the answer? So for just this much part, the answer would be dp of phi equal to 1. Okay sir. Now what comes up next? What comes up next is actually very interesting. Now let's try to calculate for 4. So 4 means what? You are considering the string CB. You only think now what happens here. Two characters which are not matching. So it can give birth to BC also and CB also. So DP of 4 is what? 2. So I've written here DP of 4 is 2. This is the way to understand dynamic programming. So if you take this like this thing now, for this much part there are two distinct strings coming up. Okay sir. Now calculating DP of 3 gives us lots of enjoyment. How? DP of 3 means you're trying to calculate answer for this part, right? B, C, B. How many different strings can be generated by doing all valid operations? My claim is that DP of 3 is nothing but DP of 4. You would say, why sir? Why sir? DP of I is just DP of I plus 1. Why? If you do no operation at B, what is going to happen? B is going to remain as it is. Now you just need to know how many variations you can generate for this much part, which is DP of 4. So what you can generate for CB? BC and CB, or CB and then BC, right? So here CB and then BC. So two ways are there, right? So guys, it's clear. DP3 equal to DP4 because DP4 means what? DP4 means BC and CB, right? Both of them can join with this B, na? This B. So there will be two ways only. So if there were two ways for this, there are two ways for this also. So currently DP3 is DP4. But this is only true if you don't do any operation at the first index 3. What if I try to swap here? What will happen? This BC will turn to CB. So a new string is coming up. This BC will turn to CB. Now you need to know how many ways are there to rearrange the rest of the part. So if this BC turns to CB, you need to know how many ways are there to fix the things from index 5 and on. But in that index 5, there is only one guy. So DP3 is DP4 plus DP5. And this formula is always true when S of 3 is not equal to S of 4. If they were equal, then you would just add DP3 equal to DP4. So DP3 is DP4 plus DP5. Why did this work out? Because I took two options. Option 1, don't touch S of 3. 3, 4, 5. You don't touch this character. What happens then? It means you can only generate all variations here. Whatever variations generated here will join with B and generate different strings, right? Already different strings have been generated here. Join them with B and they will be the different strings of length starting from index 3. So this gave birth to DP of 4. But then guys, option 2 is you do touch B and you do try to swap it. So if you try to swap it with the next character, assuming that they are not equal, BC will turn to CB. Now you want to know how many variations can be created for this part, which is DP of 5. So what is DP of 4? DP of 4 is 2. DP of 5 is 1. So DP of 3 is DP of 4 plus DP of 5, which is 2 plus 1, which is 3. There are three ways. When you don't touch it, there is this BCB and BC. And when you do swap it, BC, this original BC becomes CB and this B remains as it is one way. So one way, two way, three way. Three ways you can see. Okay, so it's so nice. It's so interesting. Ram. So everything is going all right. So you guys understand that there are three strings which are getting generated, and that those are the strings which I showed you earlier. You can see here. Okay. Now same when you go here, same formula will be applicable and the things will start working. So if I try to show you the pseudo code, okay. So here if we go, you can see that we start from the end, okay, reverse dpn1, then this one only. We go from n minus 2 till 0, okay. Initially dpi is always dpi plus 1 because you can just choose to do nothing at this current index, right, when you're trying to calculate best answer of this much part. And whatever was the answer for the previous string from I plus 1 to n, all those distinct strings just join our character without any changes. Or you can select our character and the other character and do the swap. But yes, there is always a fear. Sir. Yeah, what is the fear? Sir, what if... See, there are two options, sir, right? You are either doing swaps here or you are doing swaps here whenever you're trying to calculate the answer for this. How do we know they will be different? We did this test case right now. If you do the swap here, what can happen? It can either remain BCB or it can either become BBC. And if you do the swap exactly at index I, it will be what? BCB, so it remains that we have already counted. But now, if you swap it, it becomes CB. And this remains, see, all three are different. So that's it, guys. And in the code, actual code, you can see that, yeah, this formula has been applied and DP of 0 is the answer. Okay. DP of 0 is the answer. Here we are taking zero based indexing. Okay, so dp n minus 1 is 1 because only one character, then you go from n minus 2 to 0, and dp of n is written as 1 because you might require it while n minus 2 plus 2. Yeah, if I is n minus 2, you might require it, right? So just for safety purpose, because it can happen that the string length is only like this, a b. Let's say you call this as n minus 1 and you call this as n minus 2. Now you see that this is not matching this, so you will write dp n minus 2 is equal to, as this is not matching this, 1 though is dp n minus 1 plus dp of n, but dp of n does not exist because string starts at index 0, right? So dp of n you have to call it as 1. 1 means nothing extraordinary has happened. I leave it up to you to figure out. You can write in the comments if you can tell me why dpn is declared as 1. dpn minus 1 is 1, that's sure, because there's only one string. Okay, so these things are given. dpn minus 2 is this. So yeah, guys, I give the free live training on Saturday, Sunday, so please join the WhatsApp group. It's in the pinned comment, and do my free course and keep enjoying. We'll see you back tomorrow in the next video with some amazing DSA problems. Ram Ram, or some DSA guidelines. Ram Ram.